Fantastic. Hello, Tom. How are you doing?
Hello. Yes, not bad, thanks. Not bad. How are you?
I'm doing a 24-hour show, so who's to say, really? It continues. The show continues forever, and at the end of the show, I will sleep. But yeah, so Tom, I've got my little description of you here. You're also a maths teacher and/or education-y person who does things with maths. And bits of maths and history, and maths and space, and maths and cryptology. Do you want to tell us a bit about yourself?
Yeah, I until recently I was a learning manager at quite a well-known museum based on cryptography and things like that, Bletchley Park. I was made redundant, unfortunately. You might have heard on the news about the difficulties that have been faced there. So a lot of us ended up on the job pile, and thankfully I've managed to pick up a couple of jobs quite quickly. So I'm now teaching in two different schools in Milton Keynes and doing some other freelance bits um, all over the place. And one of the things I really want to do with the freelance side of things is get some more museums to benefit from the maths angle. So over sort of 7 years or so, we built up a literally award-winning program at Bletchley Park. And some of the awards we won were for being a really good venue for maths learning. And I'd like to take some of that to some other museums because a lot of museums are starting to do some maths now, but a lot of it tends to be numeracy, sort of learning how to multiply things quickly in your head, or a lot of museums I'm seeing are doing code breaking now, even though there's nothing to do with their museum. So I think that's great. It's wonderful that they're starting to embrace the maths, but um, it would be lovely if they started to explore the maths in their own stories that hasn't yet been brought out
Hmm.
to the public.
Yeah, well, that's cool. And I guess, that's the kind of thing that with the experience you've got, you can probably help people with that. If anyone runs a museum and you would like someone to come and look at the things you've got in your museum and tell you what's the interesting maths behind them and produce some resources and ideas and things, Tom, just, get in touch. Um, Excellent. So I believe you have a magic trick for us.
I do have a trick, and I'm calling the trick the power of five because it sounds mystical. But
Oh,
actually, it's more to do with roots. Yeah, let's get started. The trick starts off with, and maybe the people who are up at this time in the morning. Obviously, there are people from places where it's not currently morning. Well done for being sensible. But yes, I apologise. It's 6:30 in the morning here, and I, prior to today, thought that 6:30 in the morning was something made up by my parents to make me behave, and it, it's not. It's real. So yes. So people in the chat might want to play along as well. I think what we'll do is I'll do the trick on you, and I've got an example of the trick as well in the presentation up here, and I'll go through your example and the example on the presentation, and the people in the chat can try their own out on each other. So I'd like you to pick a two-digit number. I'd like you to keep that in your head. Sorry, I noticed there's a couple of people have already put a number in the chat. Please don't, because this is all about me guessing which two-digit number that you have picked. So Paddy Maths, you have picked the number 42. Am I right? There we go. That's the trick. Um,
incredible.
there's another step. The electronic enthusiast has picked number 99. Sorry, this is 6:30 a.m. maths tricks here. The actual trick is I'd like you to pick a two-digit number. Have you got a two-digit number in your head?
I have, yeah.
Good, right. Then I'd like you to multiply it by itself 5 times. So raise it to the fifth power. The
I'm allowed to
example.
use a calculator for this.
You can use a calculator. That is allowed. I'm not
Okay, fine.
allowed to use a calculator, but you are allowed to. So the example
Okay.
on the screen, I picked the two-digit number 24, and then 24 times 24 times 24 times 24. Okay, and then I'd just like you to tell me the answer to that calculation.
Okay, I have, because it's quite early in the morning, accidentally just done 24 because that's your example, and I'm just copying what it says on my screen. But I've now picked my own number, and I've done this. So I was like, oh, the answer's the same. That's weird. Oh yeah, hang on. So I've now picked my own number and calculated that for my own number. So would you like me to read out the answer?
Yes, please.
Okay, so I've got 14,348,907.
Is your number 27?
It is.
Excellent.
It
It
is.
worked. Brilliant.
Wow, that's incredible.
Yes, I was amazed and
Can I do another one?
astounded. Yeah, go for it. Go for it.
All right, I'll do
Pick
another
another
one.
two-digit number.
Oh, okay, I've got 459,165,024.
Is that 54?
It is.
Excellent. Yes, it's working. It's working.
Wow.
Not only is my brain working this early in the morning, but so is the matter. Would you like to know how it works?
I think I would, but I think I'd maybe like to let people think about it for a little bit before we do, because
Yeah.
there's obviously something maths going on here.
That's
and
a
it
good
might be
idea.
that some people in the chat might be able to have a think, or some people watching. I guess you don't have to be in the chat. But the other thing to say is, if you do know how this works, please don't just spoil how it works for everyone in the chat. As we've been saying all along, let other people have a chance to play with things. So if you do know exactly how this whole thing works, just remain smug. Just stay quiet. If you've got sort of a quarter of an idea, if you've maybe thought, oh, there's something interesting about, it's fifth powers. Yeah, I wonder how this works. Yeah, there's 2 digits in the number that you're getting. So someone suggested that they can understand how you get one of the digits, but maybe not the other one. So there's some,
okay.
we can try and break it down a little bit. We'll give people a bit of time to think about that. So in the meantime, is there anything that you're up to lately that you want to tell us about?
Trying to find work at the moment is the main thing I'm up to. I am. Oh, actually, I do want to tell you about something which is not. It's not. It's fairly dear to me, but it's not something that I benefit from personally. Now, I have a rat. I have a rat here called the rat because it is a time rat, as you can see.
Right.
And this rat was given to me by a very good friend, but it has acquired. I'll show you if I can. I'll show you a badge there. Can you see that badge?
Oh, excellent. Good.
It's a badge for the National Cipher Challenge. Have you heard of the National Cipher Challenge before?
I think I have. And I say that because I believe that I've been to one of their events at Bletchley Park.
Yes. So. Yeah. They tend to have the final not the final, sorry, the prize giving at Bletchley Park every year. I don't know how that's going to happen this year because we don't know what's going on. But it's a national cipher challenge competition. Yeah, the clues in the title, and it's aimed at school students of all ages, mainly secondary students. But there are people from primary schools who enter each year as well. And it's a competition that has 8 rounds, and each round is a block of encrypted text, and you just have to decode the text either on your own or with a team, and then you submit the encrypted text and you get points for that based on the accuracy of your decode and how quickly you've done it after it's been released. And it's a lovely challenge. I blame it for getting me to a position where I was working at Bletchley Park because before I was at Bletchley Park, I was a teacher. I was a secondary school teacher, which is why I've been able to get back into the classroom so quickly now. And I was introduced to the world of code breaking by one of the posters for the National Cipher Challenge, ending up in my head of department's pigeonhole. And then he brought it to me, dropped it on my table, and said, "You're a nerd, do this." So I did an after-school club in code breaking for interested students that I worked with, and the students taught me as much as I taught them because I'd never done any code breaking before. So we learned code breaking together, and then after a few years of this, a job came up at Bletchley Park, and I went for it. And obviously, I had a background in codes and ciphers through doing these sessions with students. It's a really, really, really good competition. This year's starts officially on this Thursday coming. It's available. There are some sort of pre-activities available, so you can can sign up, uh, get your team together, and get an idea of what's going on by breaking a couple of practice rounds. But it's a really, really fantastic little challenge, especially for those students that want something extra and something mathsy that they really want to get their teeth into. So I recommend anyone signing up. Of course, you can have a go at it if you're an adult, of course, but you can't win if you're not a student uh, at school.
Boo.
Um, so yeah, there are prizes available. There's usually one sponsored by GCHQ. I don't know if that's still going. But other sponsored prizes as well. So you do win stuff if you do really, really well. And of course, one of the great prizes is to get to go to Bletchley Park, hopefully, for the prize giving.
Yeah, so I'm just having a look at the website for the thing. Is this the cypherchallenge.org? Is that the right one?
Yes, that's the one. Sorry, that would have been really helpful,
Cool,
wouldn't it?
fantastic. I'll pop that in the chat as well so people can have a see. There's some information there, and I guess is it too late to sign up, or can people still sign up if it starts on Thursday?
You can sign up anytime you like. You can sign up through partway through the program, but
Right.
it does get progressively more difficult. So the first few rounds are
Yeah.
really accessible, and then it just is very steep learning
Yeah.
curve.
Don't just come in right at the end and
it-
expect to be able to jump
yeah,
straight in.
yeah. If you come in at round 8, you're going to struggle. Well, you might not, but
Yeah.
if you
Fair
haven't
enough.
done any code breaking before, you will struggle
Yeah.
at round 8.
Oh, that sounds really cool. Fantastic.
Great fun.
So I've been keeping an eye on the discussion in the chat, and we've had a couple of people who've got some ideas, some thoughts about how this might work. So saying we had someone who said they can work out how to do the ones digit but not the tens digit. So that's maybe one thought that's useful. Someone says, I know how it works, but I'm not sure why it works.
Oh, right.
Quite
That's
a
an
deep
interesting.
mathematical
Yeah.
thought, I guess, that I think I know what you mean, that like you can see the sort of mechanics of how it works, but is there some kind of underlying fact that makes this possible? And if so, why does that happen? And someone else has said there are no coincidences in maths, which I think is a nice thought. So do you want to talk us through this? Do you want to give us some kind of hints about what's going on here?
Okay, so one of my big bugbears about maths and about people's view of maths is that it's all about remembering lists and facts and things like that. So, and it's all about just doing calculations in your head. So, the trick I've chosen actually sort of potentially feeds into um, my bugbears with maths. But let's go with it. Okay, so how does it work? So, what we're actually doing here is working out fifth roots of large numbers. So if I take it down a bit to a smaller problem and say, okay, what if I'd asked you to pick a single digit number and raise it to the power of 5? You'd give me one of these answers down here. Obviously, that's not a single digit number. And I could feasibly just memorize this list of numbers. Okay, so and then if you said, well, I got 3,125, I would say that your original number was 5, and then you would completely not be amazed because there's only 9 numbers for me to remember here. So what we're actually doing is looking for patterns. So I think a lot of people in the chat spotted this particular pattern. The last number in the number you get when you raise a single digit number to the power of 5 is the same as the number that you started with.
That is a
So
coincidence, isn't it?
yes. So what we're actually doing is what I've done here is I've partially annoyed myself by reducing this to a problem where I have to memorize a list, and the list I've remembered is not the single single digits to the power of 5. I've memorized these multiples of 10 to the power of 5. So that's the list that I've memorized. But obviously, there are a lot more numbers than that could be chosen here. So I think that there is some magic trick going on, honest. So you can reduce these numbers here to the numbers on the previous page multiplied by 100,000. So you probably see that the numbers at the beginning here are exactly the same as the single digits to the power of 5, but then they've got 5 zeros on the end because we've multiplied by 100,000. So this list isn't any more difficult to memorize, I think, than the list on the previous page. So there we go. Now, the number, the example that I gave on the first slide was two-digit number raised to the power of 5, and we've got 7,962,624. And the first step that I'm doing is I'm literally slotting this number into the list in my head and seeing where it goes. Now, it goes between 3,200,000 and 24,300,000, which means that the answer is somewhere between 20 and 30. So the fifth root of this number is somewhere between 20 and 30. Now, I don't think that's particularly going to amaze anybody, but it is a sneaky little trick. Okay, so I know it's between 20 and 30, so that's how I get the tens digit. Now, getting the final digit, I think this is the one that a lot of people saw how to get the units digit. I think this is where they're sort of, I know what to do, but I don't know how it works. If that was the phrasing, I think. So this comes back to a famous maths person called Euler, and Euler's theorem states lots of things. Well, some fairly simple things actually, but Euler's theorem. I'm not going to go through what it actually says, but you can sort of work it through and find that for our purposes, for any integer a to the power of 5 can be written as 10 times some other integer m plus the original number. And that's an important thing. So I've put it in a box just to show that it's important, as you do. So just for example here, 35 to the power of 5 is 52,521,875. So using this idea here, we could write this instead as 5,252,184 times 10 plus 35. So our original number added on the end there. Another example, 83 to the power of 5 would be 3,939,040,643. I think I said that right. And using this, we could write it down as 393,904,056 times 10 to the power of 83. Now, this number at the end, obviously, the 5 on our original number there's a 5 on the end of the power of 5. And I think this is what some people mean by why does it work? How does it work? I know what happens, but I don't know why. If we write it down using this version here, I think it becomes slightly clearer because if you're multiplying a number by 10, so this number is being multiplied by 10, and that means that every digit shifts to the left, and then that the units digit will be filled in with a 0. And then if you've got a number, any number you like, where the units digit is 0, and then you add some other number on it, then whatever the units digit is for that other number is going to replace that 0 in the answer. So because we can write any number in that's raised to the power of 5 in this format here, or this format here in the box, that tells us that the final digit is always going to be the same as the final digit in the two-digit number that we started off with. So, so for the example, 7,962,624, we know from the first slide or from the earlier slide that its fifth root is between 20 and 30, and that ends in a 4. So it's a simple matter of just saying, right, okay, that must be 24. So really, when you tell me your number, when you work out this number, I'm listening to the first digit, maybe the first 2 digits or so, just to get the ballpark area. Then that's nice and easy to slot into the list we had before. And then I lose interest, listen to a podcast or something until you get to the end, at the end digit, because that's the only digits I really care about. The first sort of 1, 2, maybe 3 digits, and then the one at the very end. The ones in the middle, I don't care about that at all. I'm not even listening to them when you say them. So it's just at the beginning and the end, and then I can work out what the fifth root is, and then I can make myself look really clever or really nerdy, or however I want to come across with this. And that's how it works. That's the trick. It's really, when you know what you're doing, it's really, really simple.
Yeah, it's absolutely lovely. And I think because there's sort of two levels to this, I guess. There's the sense in which you can sort of know, this is what people are saying, like, I know how the tricks, but not how the trick works, but not why the trick works. I guess if you know how the trick works, you can do it, right? You can reproduce
Yeah.
this thing by, listening to the number, slotting it into one of those gaps, and then just saying whatever the last digit is. And like that on a functional level means that you sort of understand how to do the trick. But I think that there's this really nice sort of reason why this works underneath. And you might look at the list of fifth powers and say, oh, they just happen to end with the same digits as the thing that you're raising to a power. And this doesn't always work. Like if you cube digits, they don't all stay in the same place. If you square digits, they only go to one of like 5 different things. So you get repeated ones. But it's sort of a nice coincidence, but it's not a coincidence because there are no coincidences in maths,
exactly. Yeah.
And I love the fact, because in the chat we've had a comment that says, "Oh, I think it's just luck. It's just lucky that this has fallen out this way." And then underneath that, having heard your explanation, I stand corrected.
Yes.
Actually, no, maths is there for you. It's got it's making it all work. Yeah.
That is music to my ears. That's exactly. As a maths educator, I'm sure you feel the same. It's when someone goes from thinking, oh, this is just some kind of random thing, or someone's just picked this and that's why it works. Someone said it does, or it just sort of falls that way. Going from that to going, I understand that light bulb. That's the thing that keeps us in maths education, I think. Certainly.
Yeah, well, it's like you say, it's not about memorizing things, right? This is not what maths is about. It's about seeing the patterns in the universe and kind of understanding how things fit together. So,
and I think that's where the maths comes in with these things, where it goes from sort of plain old numeracy, which is doing the calculations and following the route that you know to follow, and then the transition to maths happens when you start to ask, but why?
Yeah. I remember once I was doing an event a number of years ago about kind of a very basic model for how computers work. So we were kind of building logic gates and talking about how computers work. And there was a kid there, and I said, "Do you know how a computer works?" And this little kid said, "Yeah, you move the mouse and the pointer moves around on the screen." And that was literally the level to which they'd sort of engaged with it. And I think it's the same kind of idea as the difference between owning a car and knowing how to drive a car and knowing how to build a car. Like it's sort of a different level of
how what you do to the car makes it drive as well.
Yeah, exactly. And like you can get, you can spend your whole life just functionally driving a car, and whenever it needs fixing, you can take it to the garage. But if you don't know actually what's going on, then whoever runs the garage might be able to, charge you more or tell you something needs fixing when it doesn't. And in the same way, you can get away functionally with just sort of using maths as a tool to, do your finances or whatever. But this is kind of really peeling it apart and looking inside and seeing what's going on with it. So I really like that. That's very cool. Very, very cool. So thank you very much for joining us. This has been a really nice little half hour of trick. I think people in the chat seem to have been having fun with this as well and enjoying this. And there's still some ongoing discussion as to why this might work and what other powers it might also work with and things like that. So that's fantastic.
Brilliant.
That things can go off in other directions as well. So I'm going to say thank you very much to Tom. And
thank you very much for having me.
Watch the rest of the show and tune in and see how it's going. But tune in by 9 o'clock tonight. We'll all be kind of slightly falling over, but hopefully still here. And yeah, fantastic. So I will go on to do my standard pluggy thing. So feel free to disappear.
Brilliant. Thank you very much.
Thank you.